So today we're going to be graphing more piecewise functions. I'm going to do example 1 and 3 with you. You're on your own for our numbers 2 and 4. So taking a look at number 1, we have two functions that we're going to be graphing. One looks like a linear function because it's in the format of y equals mx plus b. One looks like a quadratic function because it has an x squared term. For the first one, we're going to graph it over the interval of x being less than or equal to -2, so only points less than -2 or equal to -2. And 8 minus x squared is going to be graphed over the interval of x being greater than -2, so only points greater than -2. And we'll start with an open circle at -2 to show that that's not really part of the function. So taking a look at the first part, we go into our calculator and we enter in those two functions. And pull up a table. And we can see our values that we need here. So remember, for 3x plus 5, we want everything less than -2, less than or equal to -2. So I'm going to go a couple points below -2. I see on my x-axis that I have enough points to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I could start at -10 on my table. So at -10, I'm at -25. Obviously, that's not going to work, so I'm going to scroll up. I have 2, 4, 6, 8, 10 vertical boxes as well, so I need to go as low as -10. So that would be -5, -10, so left 5, and down 10, all the way at the bottom. And then it has a slope of 3, so I could just follow that up 3 over 1 pattern. Next point is at -4, -7, which is up 3 and over 1. Next one's at -3 and -4, which is right here, so up 3 over 1 from the last point. And then the next one is at -2, -1, which is up 3 and over 1. And we can put a solid dot there since this is less than or equal to. And we can extend our line down with an arrow at the end, showing that that would continue in the opposite direction and we don't have a limit on that end. Now we go over to our other function, starting at -2. We're at +4. So although it says everything greater than -2, we're going to start at that -2 with an open circle at +4. So that's not including that point, but it's including anything past -2. So -1.8, for instance, would be part of the solution set. And then we go to -1 and 7 with a regular circle, 0 and 8, 1 back down to 7, so 0, 8 is our vertex, 2, 4, 3, -1, 4, -8, and that'll probably be the last one I can fit. So I can draw my quadratic function up and then back down with an arrow on that end. So this drawing here is the piecewise function f of x equals 3x plus 5 over the interval where x is less than or equal to -2 and 8 minus x squared over the interval of x being greater than -2. Okay, so I'm going to jump to number 3. You can pause and do number 2 at this point. Okay, so for number 3, we have 3 functions. So I'm going to enter all 3 into my calculator. (2x minus 7 is the first, -x squared plus 8x minus 10 is the second, and -2x plus 9 is the last. And I'm going to pull up the table. So I have all my values set. Now for the first function, it wants everything less than 1. So if you notice, the first function less than 1 would be -5, -7, -9, -11, -13, -15, and so on. I have 2, 4, 6, 8, 10, 12, 13 boxes to work with. So -13 is the lowest I can go at -3, -13. So I'll start with that point. Then I'm following an up 2 and over 1 pattern. Negative 2, 11 is up 2 over 1 from there. Negative 1, negative 9 is up 2 over 1 from there. 0, negative 7, up 2 over 1 from there. And 1, negative 5 is up 2 over 1 from there. Now notice this says less than 1, so I'm going to put an open circle at my positive 1 and then draw my line showing that this would continue in the opposite direction, anything less than 1. Now going to my next one, starting at 1, I have 1 and negative 3. So I'm going to graph that point, 1, negative 3, with a solid circle because of the less than or equal to. And then I'm going to follow that all the way to 7. So 1 is negative 3, 2 is 2, 3 is 5, 4 is 6, being the vertex. So now we're going to go back down the opposite way. 5 is 5 again. 6 is 2 again. And 7 is negative 3 with another closed circle. And I can draw that part of the quadratic function and part of my piecewise function. And then I go on to the last function. Starting at 7, I'm at negative 5 for negative 2x plus 9. So 7, negative 5 would be our open circle. And now I'm going to follow the down 2 over 1 slope. So 8, negative 10. Sorry, 8, negative 7. Then 9, negative 9. And 10, negative 11. And lastly, I can fit 11, negative 13. And draw my line down with the arrows on the end, showing that that function would continue increasing in that direction, or decreasing in that direction rather. All right, so from here on, you should understand what a piecewise function should look like, when to use a solid circle, when to use an open circle, and you can try the last function on your own.